Today's daily code problem of the day is best sightseeing pair number 1014. For this problem, we're given an integer array called values, where values of I will represent the value of the ith sightseeing spot. Two sightseeing spots, I and j, have a distance of j minus I between them. The score of a pair, I is less than j, of sightseeing spots is the values of I plus the values of j plus the distance I minus j. The sum of the values of the sightseeing spots minus the distance between them. We want to return the maximum score of a pair of sightseeing spots. So we're trying to find the two best spots based off their quality or their value and their distance between one another. So if we look here at example 1, we could take a look at the values. So 8, 1, 5, 2, and 6, those are the values. And then we can label their positions 0, 1, 2, 3, 4. And those would be the distances between two values. So our output for this problem is 11. And all we have to do is simply calculate the best value based on values of I plus values of j minus the distance between I and j. So if we look at 8 and 1, 8 plus 1 is 9, and the distance between them is 1, because I0 minus 1, so negative 1. So 9 minus 1 is 8. And then we can look at 8 and 5, so that's going to be 13, and the distance between them is 2, which is 11. That ends up being our best possible value pair. But we could keep looking, so if we have 8 and 2, that value pair is 10, and 3 minus 0 is going to be 3 distance. So 10 minus 3 is 7. And so on and so forth. That's all we have to do for this problem. So our goal is to find the two indices such that they fit this problem. And our approach, we're going to use two variables, our maximum left value, which is going to track the max value of values of I plus I as we iterate, and a max score, which is going to track the maximum sightseeing score so far. We'll simply iterate through the array while calculating the values of j minus j and combining it with the max left and update our max score. So it's kind of like a brute force method, but a little bit more efficient. So we're going to have our int max score is going to be equal to our integer dot minimum value. That way nothing will be smaller than it. It will only ever be greater than it. And then we have our int max left value, which is going to be equal to our values of 0, since that is where we're going to start. That's our first value. Then we can simply iterate through our array from the second element onwards and constantly update the max score. So for each integer j is equal to, starting at 1, as long as j is less than our values.length, j can increment. So our max score can be updated by doing the math.max function and giving it either our max score or our max left plus our values of j minus j, because we are subtracting our j value here. So then we can update our max left if our values of j happens to be greater than the current value of max left. So max left will be equal to math.max, our max left, or our values of j plus j, because we would plus I here. So values of I plus values of j minus j. So this is going to be values of I plus I. This is going to be values of j minus j. And this simply, even though it's j, because that is our index representation, this would be values of I plus I. And that's all we have to do for this problem. We can simply then return our max score. So if we run this, and if we submit it, passes all of our test cases and all solutions. So earlier I compared it to being similar to a brute force method. That's because we are checking all possible combinations from a local maximum. So 8 happens to be the maximum there. So we check until we find a new max. In this situation, we never find something greater than 8. So 8 always stays as our max left value. If, for example, 5 was a 9, we would check 8 against 1, 8 against 9, and then we would update our max left to be equal to 9. So then we would do 9 and 2, 9 and 6, so on and so forth. And it's similar to our brute force, where we would check every possible combination, but we only check the combination if the left value is a max. So that's it. Thank you. Follow for more daily code solutions, and I'll see you tomorrow.